the seminar is starting, I will start by introducing the 4 speakers, and in the meantime, please feel welcome to continue introducing yourselves on chat, and we will have a look at the chat later. Our seminars are intended to be very interactive, and the speakers as well are invited to follow up on any points or questions that were raised via chat, not only during the Q&A session. So feel welcome to make the most of the chat. We have today 4 amazing speakers from 4 different institutional contexts that have been doing a lot of work on challenge-based learning and introducing real-life projects in engineering education. Our first speaker will be Christian Herzog, who is a transdisciplinary researcher combining technology and applied ethics. And since 2015, he is a member of the Institute for Electrical Engineering in Medicine at the University of Luebeck, where he has committed to making ethical considerations integral to technology development. Our second speaker will be Kyriaki Papageorgiou, who is a director of research at Fusion Point ESADE Business and Law School. Her work is located at the intersection of anthropology and science and technology studies, and her research examines policies, discourses, and practices of innovation in tackling big societal challenges, as well as the emergent role of robotics and AI in transforming work and daily lives. Our third speaker is Emanuele Attili, a professor of engineering education and director of the Integrated Engineering Program at UCL, which is an award-winning teaching framework embedded in the learning experiences of undergraduate students across UCL engineering, aimed at better preparing them for tackling future global challenges. And before becoming director, she led the establishment of problem-based learning through the creation and implementation of IAP challenges and scenarios aimed at introducing and engaging first and second year students from across the faculty to experiential research, team-based, interdisciplinary, and authentic learning. And finally, we have from Mexico, Jorge Membrelo Hernandez, who has a PhD in environmental and sustainable biotechnology from King's College of the University of London. His work has consisted in carrying out several sustainability-oriented projects, including as head of advisors of the public administration of the World Heritage City of Xochimilco. And before joining Tecnológico de Monterrey, Jorge was a professor at King's College, Sheffield University, Harvard University, and the National Autonomous University of Mexico. So we are very lucky to have these 4 amazing and diverse speakers with us today. And now I give the floor to Christian, our first speaker.
Yes, thanks a lot. Thanks a lot for the kind introduction, and also thanks a lot for giving me the opportunity here to present some of my work. Yeah, I think this is a very nice opportunity to really engage with other people who are interested in the scholarship of teaching, so to say. And well, having said so, I must really apologize because I need to leave after my presentation and the Q&A section, and that is very, very unfortunate, but there has been a committee meeting coming up, which is also very, very important, which also involves the leadership of my university, and well, and it was beyond my control to actually change the schedule there. So I hope that you can apologize this, and yeah, what I want to do is I want to basically discuss a course that I've been teaching now as Diana introduced me as a transdisciplinary researcher, and I'm taking what I call a constructive approach to teaching engineering ethics by using challenge-based learning and partnering in doing so, partnering up with startups that present real case studies. And I'm not doing this on my own because I'm fortunate to have a team of very motivated and very diverse researchers and students with me. So there's a picture missing. I didn't yet get around to take a picture of Noah, but I'm very fortunate to lead a group that I call Ethical Innovation Hub, and the idea behind the Ethical Innovation Hub, very briefly, is that I, coming from an institute that is actually an engineering institute, is not, well, we don't have a lot of people proficient in humanities, ethics, and whatever, and I've basically come around to well, I call myself transdisciplinary right now. I'm more trying to get into the humanities deeper, and I have to acknowledge that I didn't really study philosophy or ethics from the ground up, but actually I did an engineering degree, bachelor's and master's, and also did a PhD in control theory. But somehow I always was interested in sustainability issues and also in ethical issues, and I also found this kind of systems theoretical approach or perspective that I can bring into this very, very enlightening. Sometimes it just feels that these kind of ideas, they flow well together. And of course, systems theory is not a thing that's only available or used in technology, and probably that's the reason for this. But then later on in 2018, actually, I chose to pursue another degree, having already taught in engineering ethics for some time. I felt that I needed to ramp up what I'm able to say and how I'm able to substantiate what we can do. Also perceiving that the students really wanted to know more. And I think that was very encouraging. So from my perspective, I think there's a strong desire of engineering students to actually go beyond their own discipline, learn a thing or two about philosophy. Not too much. It needs to be practical. That's still something that I feel that comes from the student side when I teach. But anyway, so that's what I wanted to be able to deliver, and also do research, of course, in this area. And then I started by acquiring some grants where I was mildly successful to get PhD students who are deliberately chosen from a broader range, and that actually facilitate my weaknesses and each other's weaknesses. So we have Sabrina Breyer from practical philosophy. We have also with a business background, I might say. We have Arne Sonar from cultural sciences, who's our most fundamental philosopher in a sense. Then we have Robin Preiss from ethnology and social sciences. And actually one thing, maybe we can discuss this later, because for tutoring, I hired a student who actually is a course graduate and did very well. And it was just an idea that maybe he can also provide supervision to a student group and do this. It's an experiment, and I have to say that this winter term it worked very well. So this is my team. So we are a group of 5, and we can also then share responsibilities in the course design. I think I need not dwell on this issue too long, but why I'm presenting this slide is actually that this is what I tell the students, because there's obviously some students who always feel like, why do we need an ethics course in technology at all? But I'm very happy to say that actually that ethics of technology is relevant also in engineering sciences. It's actually a mainstream position right now. And that I think when I started out, when I studied, that was far from it. We actually had a student group and did peer-to-peer teaching, so from students to students, about sustainability issues, because at a university, which is Hamburg, which was Hamburg University of Technology, which has a huge department for process engineering, which has energy sciences and all this stuff, there was not a single course focusing on sustainability. I think that this is kind of a disgrace. And currently, I would even see this as a disgrace. Unfortunately, here at the University of Luebeck, we have such a thing. We have actually one single institute that kind of is building a spider web into all the study programs, presenting at least one course that not only goes into the ethics, but also goes into philosophical issues. And once we started a new robotics and autonomous systems degree, I was actually a strong proponent of introducing an ethics of technology course there, and that's where we are now. So we have a mandatory ethics of technology course. That's what I'm talking about. That's what we do. So what I want to do is really well written here in this citation, in this quotation. Technologies have a clear moral dimension. that is to say, fundamental aspects that relate to values, ethics, and norms. And those technologies reflect the interests, behaviors, and desires of their creators and shape how the people using them can realize their potential identities, relationships, and goals. And I think if students really take this away and have really understood the depth of what this quote means, then I've already achieved something at my university. So there's a list of learning goals that I want to briefly discuss, going from the top to the bottom. So of course, I want the students to understand some of the fundamentals of the ethics of technology and AI. So ethics of AI is definitely a focus in my course. So that's one thing that I wanted to tell you. And well, I think one way of going about this, of course, not the only way, is that at least students go out of the course and they know some of the most common issues that need to be thought of. So as to have a kind of a simple compass, a radar on what to think about. Conceptually, also to extend this knowledge, and also very practically. And that's really where I try to strike the balance. So I want to have them to be able to relate conceptual ethical implications to practical applied examples. I'm later going, in the next slide, I'm going to tell you how we try to do this. And I want the students to understand the complexity of the processes of technological innovation. So what is their role? They innovate or in the future they will innovate. And that's not just bringing something out in the world, but it's happening in an ethical and societal context. And therefore also this means that the students, or then the prospective engineers, they also carry responsibility for what happens next. And these issues or contexts, they need to be able to communicate within these and debate about these socio-ethical questions. So debate is a strong item that I want the students to be able to engage in, using the appropriate terminology and also, of course, the arguments. I also, and that's a little bit hidden in here in this learning, I also want them to be working in interdisciplinary groups. So while our university is mostly a university of students of medicine and computer science, actually, there's also some engineers, there's also psychologists, and also some computer science focusing on media. So this is as interdisciplinary as it gets, unfortunately, I might say, but of course, that's how the situation is. And I want to bring together these kinds of people in the course, even though it's a mandatory course. So there's a little trick that I employ to actually also bring in some psychology students and students from other degrees, even though the course itself is mandatory in the robotics course study program. Okay, so maybe the most important thing here is also the bullet point that is last but one. Even though I'm dealing mostly with engineering students, I want these engineering students to be able to conceive of solutions that are both or either or technological or non-technological in nature. So I don't want them to focus solely on what can I do with technology, but I also want them to be able to take a step back and say, okay, this is something which has several solutions. Maybe the technological solution is not the best one. It can take a backseat. We have an idea, we can bring it up if all else fails, but maybe the better, the most cost-effective, and the most social solution would be something that is not purely, at least, technological. And I think this is something that is really difficult for some of the technology students, because that's what they want to do, obviously. But working in interdisciplinary groups, I think that opens up their perspectives, and they might even feel joy in devising concepts and solutions, conceptual solutions that are not in their main area of expertise. So how do we want to do this? Of course, Diana also already highlighted or outlined or spoiled that we are doing challenge-based learning. That's the basic idea. And we do so because we want to create both a real and a perceived educational gain. So the idea is actually that instead of just, I'm not saying this in a diminutive manner, just talking about ethical issues, but actually using ethics and not only as a way to find the problems, but also maybe to find positive direction. So what if I deliberate about the ethical issues of some technological approach or some business model, how can I use ethics to think about what actually is going to be better afterwards? And what is the basic or value-based motivation for engaging in this kind of innovation? Because also that's something where I, when talking to students, are always faced with. They perceive ethics as something that is maybe another barrier that I now need to be able to do, and that's actually something that is breaking, or that's hindering innovation. I don't think that's entirely true. I think sometimes ethics needs to be able to stop some kind of innovation, but if you want to so to say ethically align an innovation, then it actually gives you new ideas on how to proceed and how to actually bring about the changes that you actually conceived of, reflect on those changes, reflect on the value basis of those changes, and maybe even pivot in the name of startups to be more certain that your kind of positive impact will actually come about. And one of the other major challenges is that I think most of the engineering students that I face really have a lot of trouble to actually communicate about these issues. So they are lacking the terminology, they are lacking some of the concepts, and they lack practice in talking about these issues. So this is something that we want to tackle mostly, and we do this or have done this, I need to be precise here, in a flipped classroom manner, where we have topical modules that introduce the basic ethical aspects that can be faced in technology. Of course, it's only a selection, so we focus mostly on AI because that's what the main contents are in the study program and also at my university. And I always structure this as providing an introductory video, which is really easy to digest, have a module text about 4 to 6 pages that we've written ourselves, which is also easy to understand. You don't need a lot of philosophical background. So we'll introduce everything step by step, but also for those that want to go deeper or that go in some kind of project, there's also a first hint at a scientific article that can be used as a starting point for future research. I have to say that I actually ditched the flipped classroom thing, but I'll be getting back to that. So at least this term, I've been trying to do a regular lecture on this, a very interactive one. And my perception is that it works far better, at least with the students that I have. And the core, of course, of the challenge-based learning approach is that we have so-called stakeholder projects, where students are interacting with, in our case, startups from a local startup accelerator, or also companies that have now grown out of the startup phase and are actually gaining momentum. They interact with these startups. We moderate that interaction, and in engaging with their business models and their technological approaches, the students identify actual, real ethical challenge from the results from these discussions, and then propose typically conceptual solutions. The students are actually also encouraged to even implement something or even work something out more in depth. I have the feeling, so we didn't yet really get to that point where we moved beyond concepts. But anyway, the startups are interested in concepts and conceptual solutions as well. So that's at least something. And one of the major pillars is also that afterwards, and when they finalize the projects, they also publicly present this. In fact, this term, Corona, makes it a little bit difficult to publicly present this. And our virtual presentation last year didn't go so well, to be honest. So we did this in a smaller venue with only the startups and the other student groups. But there's lots of material being created, so we can always go back to this and ask the students to maybe take the stage later on. So that's the basic concept that we follow here, and a little bit more in depth maybe is that we actually have a kind of intermittent sequence of topical and stakeholder meetings. Stakeholder meetings, that's the name that we if always when the students are interacting with the startup itself. And topical meetings is something that we do together with the students without these startups. So the students prepare a topical module based on these 3 items that I just mentioned. They reflect this and they prepare a brief poster slide. So where they so this is really something that they should do ideally in presence, but well, virtually the last 2 years. Just produce a slide in 30 minutes time or so, putting all the reflections that they have and everything that they've, not so much what they've learned, but how they relate this to their startup, their stakeholder project. So for example, there's the topic of human autonomy. How is this infringed upon, or maybe not infringed, enhanced in this kind of startup business model or technological approach? Sorry. Then we discuss what they found and what they put on the poster slides in a topical meeting with themselves. We derive questions and ideas from them, also letting interact those students among each other. So students from groups, maybe that has become clear already, but I didn't really say it. And these questions and ideas are then brought forward in the stakeholder meetings, proposed basically to the startups, to representatives of the startup. What do you think about this? So we have seen an issue. Have you thought about this or not? And I think this is really this is a crucial point, because typically the students at the very beginning are very critical, and I like this. And then they engage with the stakeholder, and some of the startups are like, no, but this is not an issue. So they are very defensive in nature sometimes. Some also are very constructive. And then we have the task to really moderate this exchange, to actually not let the stakeholders dominate the discussion so much, because some of the students really easily back down and then say, okay, oh, you've considered this not an issue. Okay, no, okay, I'm fine. But they don't really ask, sometimes at least, they don't ask, why is this not an issue? And that's really what we want to bring them to. So we want our students to be critical friends for the stakeholders. And therefore we need to manage for a situation where they really can engage with each other in a kind of safe sandbox. There's a special agreement and nothing will get to the outside, and everybody can be blunt and very open, and ideally really start a reflection process, not only in the students, but also in the representatives of the stakeholder. That's at least the general idea, and we are still in the process of assessing whether that actually works, to be honest. Sometimes I think it does, sometimes I'm not so sure. But really our duty is to basically guide the students, make them more critical, make them very constructive, make them positive in their thinking, but also encourage them to actually raise their voice in a very fair and a very polite, but also in a critical manner, of course. This is just a brief outline of what we actually talk about, and I'm continually trying to update what we can talk about in this flipped classroom style. And the idea is actually that later on students can select the topics that they want to go deeper into. So having more modules, then you can actually teach in a kind of lecture-based framework. And if students then in the end or in midterm kind of decide that human autonomy is the basic direction, we need to go deeper to actually be able to say something about this, then we provide them with new material. And that's usually the genesis of a new topical module that we also write up and could hand out later on. So most of this is dealing with AI. As I said already, it's a little bit structured into very basic things. So we also have the fundamentals of normative ethics, and intermediate things like nudging, and something which is sometimes very specific, like issues of in algorithmic bias or data provenance, for example. Just as well, telling you what we actually dealt with in 2 iterations of that course, we each had 5 startups that contributed. Here ranging from an edge AI, a solution for surveillance systems, which is of course very, very sensitive, and a deep learning based mobile blood analysis framework, predictive analytics for food sales, off-highway navigation, which kind of tries to strike the balance between being sustainable and also, of course, giving people the liberty to to drive scenic pathways, and a deep learning based sensor fusion armband for providing positive feedback and rehabilitation. That's the last year, and currently we are not yet really finished. So currently, actually, we are in the process of grading the project reports. So students have to write a project report and present a final poster in the end. And they actually have to write something down. They have to actually argue. And this time we have personalized AI-powered nutrition. We have job orientation and matchmaking. So it's not AI-based hiring algorithms, but it's very close. So it's also a hot topic. Predictive analytics for personalized fitness. An online platform for matching patients in cares and palliative situations, and autonomous ferry systems. So you see, most of the time AI has some role here. Sometimes the startups are only thinking about employing AI, and that also is something that is usually very, very fruitful, because then the students can actually make a prospective analysis, whether that would make sense, what would be the ethical issues then that occur. And that's a real gain, I think, to the startups if they then get the project report afterwards. Now we're facing a few practical challenges. For example, when we try to acquire startups, they may at first not really see the value. And to be honest, some of the startups don't see the value at the very end, because there's obviously always student groups that are not that strong, and then the outcome is I don't know, C-. And despite our efforts, we could of course then not really make a convincing case. Please continue to cooperate with us next year. And then unfortunately, startup is very disappointed. But I think our situation is very good, because the Startup Accelerator has new batches coming in every 9 months. So we will have new startups that unfortunately didn't see the good students, but also they didn't see the bad ones. So we always have a fresh start here. And I think that makes for encouraging new situations also for us as teachers, and every time. We also always negotiate how much time the startups will be able to pour into this. So last year we had them meet every 2 weeks, which was very nice. This time we had them meet 3 times during the whole term. So at the beginning, midterm, and the final presentation, which is of course not that much, but there's also pros and cons for this. Maybe we can leave this up to the question and answer session. As I stated, students are sometimes overly critical at first, but then it's actually managing, it's our task to manage them to be critical friends, rather than trying to please the startups. And that really, what I've seen really happens. They fail to distinguish between who actually gives the grade and what I'm working for. And maybe this is also because they really like the startup and would like to work there. I don't know. I've not analyzed this yet. So we've actually went away from flipped classroom, because I think that might work better in familiar learning settings, but our ethics of technology course is really something new for the students. So they have not had any other argument-based philosophical course before that. So it's in the 3rd semester. They don't really know how to write essays. So really, I think it's much better that I switched to a lecture-based framework, but my lectures actually, I'm talking half of the time and students are talking the other half. So really, I pose questions, and then the questions of the students just keep coming. And that's also really encouraging. So we have a discussion based on topics rather than I am the one lecturing everything. And that works very well, I think, at least this time. So we're also facing always the problem. Some of the startups approach us and say, okay, we have 2 very imminent ethical issues that we want to get covered. But we, of course, want the students to actually discover these ethical issues themselves, because I think that is even more valuable at some point than actually answering these ethical issues, because students need, in their later profession, they need to be able to discover the ethical issues. They need to be able to actually see them. And that's one of the main learning goals. And we are trying to everything in between, or what's the sweet spot in between. giving them some pre-discussed ethical issues and leaving them this as a selection, which would not be challenge-based learning in my understanding, actually, or really going for the full-blown challenge-based learning approach where students really need to make the choice themselves, of course, with our supervision. I think I slipped in some of the evaluations that we had and lessons learned already. So to be honest, we pour in a lot of time and effort in the material and also in the structuring of the course, making everything clear from the outset to the students, but somehow the course only scores on par with everything else that the university has on offer, which is not bad at all. I think there's good teaching to be done at my university, but of course we would like this to be a very special course that all the students flock into and say, okay, that was really worth the while. Maybe that's too much to ask because it's just so alien to what engineering students usually do, and there's always some students who just say, okay, this is something I need to do, but I don't really want to do. So, but to be honest, I also had taught ethics courses, which were even more free, kind of seminar-based way, and that always scored very, very well. So I'm still trying to get to the bottom why there's some criticism that doesn't get voiced constructively, but just ends up to be lowering the average grade in the end. And of course, everything that I now explained, even though students report that they don't pour in so much time, they still feel kind of overburdened with the tasks. So they need to do a lot of things that they're not familiar with, like writing essays, talking a lot, preparing these meetings, and also engaging in maybe ways that they are also not familiar with, like drawing a poster, which could also be a very creative thing to do. So some students really just write down bullet points, that's fine, but we also encourage them to actually draw images and then take this as a basis for discussion, which rarely happens, but when it happens, it's really fun to do so. So that's also one thing that we took away, maybe structuring the course in a very easy, in a very in a way that doesn't seem so alien to the students. And that even goes down to fixing the terminology in terms of lecture and exercise, even though that's not what it is, but that's familiar to the students from engineering. They are used to getting a lecture about, for example, engineering mechanics, and then going to an exercise where they apply what they've just learned. And by just using this terminology, we were hoping that they wouldn't perceive this as too different from what they are used to, and maybe then also lower some of the barriers to actually engage with the material instead of engage with the organizational issues. But we're also not there yet, I would say. And yes, with that, I thank you for listening, and I'm looking forward to your questions.
Thank you, Christian. And as we are short on time, I will invite any questions or comments to be posted via chat and to interact with Christian via chat. And I'm now giving the floor to our second speaker, Kyriaki Papageorgiou.
Hi, Diana.
Hi.
Let's see if I can just put it on full screen. Can you see it all right?
Yes, we see.
Perfect. Hi, everyone. My name is Kyriaki. Thank you for having me in this SEFI webinar. Just begin by saying that I'm a cultural anthropologist by training, and I kind of came to this very special course called Challenge-Based Innovation 7 years ago, and I'm very happy to be presenting this course today to you. So the main goal of CBI is to generate new ideas and develop prototypes that address grand societal challenges inspired by CERN's open science, technology, and its experts. So CBI actually brings together engineers with business students and designers under the umbrella of CERN to kind of deliver a very unique learning and innovation learning experience. This course brought together these three schools together, ESADE Business School, the Polytechnic University of Barcelona, and the Institut Europeo de Diseño in Barcelona for the first time in 2014, as I said. And then eventually we actually formed a memorandum of understanding between the three schools, and we called ourselves Fusion Point, kind of like an homage to CERN that brought us together, with the main goal is to tackle real life challenges through interdisciplinary collaboration in education and research. And Fusion Point belongs in the Design Factory Global Network. I don't know if you know it. It's a Aalto University initiative that also are collaborators from CERN, called CERN Idea Square. They also belong. So this is the image from CERN's Idea Square, and they do have a London kind of bus in the middle where you can have meetings. So there is a main kind of, as I said, there's a main kind of a mother project where CERN has a collection of all sorts of different iterations of the CBI course. And it's not just us, Fusion Point, that has a course, but like there's many different versions of CBI that have developed over the years. And our version, the Fusion Point version, has kind of main characteristics. It's multidisciplinary, whereas in other versions it's only engineers or only designers. It's experiential. We want to make an impact that is socially relevant, and then of course it's challenge driven. Part of the kind of the reason why we kept it started from bottom up. So it started with a group of teachers coming together, and part of the reason that we managed to reach the deans and the rectors, and eventually became like an initiative between the three schools, was because of some of the let's say attention it got from media. So what I will do now is I'll give you a very, very brief overview to give you like a taste of what the students do in this course. Is that from the beginning, they always start with the societal challenge, and it's delivered to them in very broad terms. So for example, food security, and this is kind of the device that they detected, enhancing movement to reduce breaking for women when they fall, osteoporosis, like water safety, refugee camps, improving the situation of life quality there. But what happened over the years is that starting basically after 2016, with the launch of the Sustainable Development Goals, we started formulating our challenges around that. So we started giving students, a sustainable development goal, and delivering to them in different ways. In one case, in 2018, for example, we just gave them, do something with gender equality. We didn't specify what they could do, and then they just, or clean water and sanitation. But other years, like in 2019, we actually focused on specific targets of the Sustainable Development Goals and had 4 teams, 4 challenges, and 8 teams working in parallel to tackle like specific targets. 2020, we focused on the pandemic, and which we also connected to different specific SDGs. And then this year is climate action. So this is how we present the learning objectives. This was the first year that actually tried to kind of identify unique kind of not only knowledge, but also skills, competencies, and values that we're trying to develop to the students through this course. It goes without saying, you know, climate change is one of the most important challenges we've ever had to face as humanity. So it's been very interesting giving them such a goal to tackle in the course. But within that, I'll give an example, just a very brief example, how we deliver the challenges this year. Again, there's 4 challenges and 8 teams of on average 5 students, having with engineers, designers, and business students. And we start with a very broad challenge, the future of forest and forestry. You know, how do we use sustainable managed forests and forest-based resources? Another challenge we gave, for example, is renewable and affordable energy, or reducing the greenhouse emissions from farming. And what we also try and give them at the beginning is a few key stakeholders from the ecosystems that they can reach out and interview. And so during the first week of the course, we actually make the first introductions ourselves. There's a big actually support group that is involved in CBI, not only faculty, but also admin staff. A lot of work that goes into planning this together. And then they kind of reach out to the companies and arrange the first kind of meeting with the students. As I said at the beginning, you know, it's a journey, CBI, it's a learning and innovation journey. And this is how one attempt that we had to describe the course. And the 3 colors represented the 3 colors of the schools, moments where students go in all different directions, come together, which is kind of reflects a lot the design thinking process, if you know it, which is this innovation process where students spend a lot of time at the beginning understanding and empathizing, and then they get to reframe their challenge, focus it, and then they start this process of ideation and prototyping at the end. This year, also very interestingly, is we're trying to combine design thinking with futures thinking and systems thinking. And it's been very interesting bringing all these different innovation approaches together. But it makes sense for tackling challenges like climate change that require kind of, you see like here, design thinking is more kind of in incremental attitude to change, whereas if you move towards future studies and future, you become a little more transformative, which is also one of the things that our partners at CERN always push us towards, like more bold and disruptive and transformative ideas. One of the things that we also highlight in the course is that it's an emotional course, like all innovation journeys or any attempt to create big ideas involve a lot of emotions. And this is where coaching, that Christian also mentioned, it becomes an important, plays an important role, you know, in this graph. You have family and humor, and then in our course you have, you know, teammates and coaches that are trying to kind of get you out of this dark swamp of despair that comes you encounter in any innovation journey. This is our course, how our course is kind of organized in practice. So we have, it's a 12-credit course. The engineers that take this course are usually our 4th year engineers, and then sometimes we have master students in the telecom engineers. And then there's MBA students, and then designers, usually sustainable design program, but we also have graphic designers or product designers. It's a 12 to 15 week course. This This year it's the shortest course we've ever had, because partly we switched our calendar so that the students had a better chance of actually going to CERN. And actually they're going tomorrow for this course. But usually we have three trips to CERN for the students. This year we're only going once. We feel very lucky to do that, actually, considering everything. And then we have weekly meetings. We call them Cbi Thursdays. And we have kind of two ways that we structure these Thursdays. One is like a coaching Thursday, and the other one is a workshop Thursday. So we always start with a large group meeting where we kind of reiterate where we are in our journey, what we're doing today, and then we do other workshops or coaching sessions. This is kind of what we expect. This is an example of a final deliverable of CBI. As you can see, it has to be, they have to have like a prototype. They have to build a prototype, and I'll give you an example of the students actually built that. The designers did the design, and then the engineers kind of, put all the electronics together, and then finally, the business students try to kind of do a business model canvas and figure out how could that be an initiative that is sustainable. I wanted to save time for discussion, and so I went through everything very fast, but I'm happy to elaborate on what I've said. But just in closing, I wanted to say that CBI has been, for me, the last 7 years, a very challenging initiative, and an initiative that I've spent a lot of time thinking about how it forces us to do things differently. And then I had a project and a big team of collaboration with other researchers in a project called Vision. And then we co-authored this book that has just come out, and it's free online. But what we've tried to do in this book, and we did this book from me having CBI on mind, is how CBI is kind of forcing us to shift the way we think the main pillars of modern education, from the way the spaces of modern education, the subject matters, the role of the teacher and the student, to the way we evaluate the students and what we ask them as the final deliverables and outputs. And of course, I can talk more about that, but this is kind of what I wanted to share now, and just open the floor. If Diana, you agree to kind of, if people have any questions, and I can go back. I did it very fast, and elaborate or talk more about anything that people find interesting. Thank you,
Kyriaki, for your suggestion and for your presentation. And I invite the participants to interact with points you raised, or ask any further comments and questions. Please raise your hands. Dimitra.
Hello, thank you so much for what you shared. I'm also working on a CPL part, and I found very interesting the design that you showed us of like how everything was combined in terms of design thinking, and yeah, this one. So I was wondering, how come you actually moved towards this combination, and how did your students, in terms of like their team product or like teamwork, experienced it? If you had any feedback on that.
So they are now in the final week, final 2 weeks of the course. But they had their a checkpoint presentation last week. And what we find very interesting is like forcing them to think not only in terms of, because what the difference between systems thinking and futures thinking with design thinking is that it forces you to take a more of a helicopter view of the problem. And for that, we used a lot of the tools that Oxford Business School has created. It has like an initiative called Mapping the System. So we used some of the tools like Impact Gap Canvas, I don't know if you know those, or like Iceberg model. And then we found that the students actually had a better understanding of the problem. You know, in design thinking, you start just by interviewing people, whereas the systems thinking, like the students did a lot more kind of background research, and we found that taking a kind of a helicopter view of the problem is very interesting. And then futures thinking, again, what forces the students to do is think of how their present solutions, or when they started thinking about what we want to do today, fits in what they think of desired future looks like. And so we always ask them, you know, because I think sometimes we want to like do something today and then without kind of exploring more about what is the future that we want, no? And so futures thinking, we found this year that we introduced this, it's helping them better kind of think of a desirable future. And then part of their deliverable is not only to prepare the solution, but how does this solution fit with the future that you want? So that has been very interesting so far. And yeah, I mean, I can share the link for the April 7th when the students will be doing their final presentations. But then maybe you can ask me then how it all went. It all kind of came together. So now it's like the critical final 2 weeks. But I think I've seen quite positive things happening when kind of forcing them to kind of oscillate between just this design thinking, down to earth, talk to users, and just having this more kind of futuristic, ambitious system approach.
Yeah. And sorry, I see Nina also has her hand raised, but just a follow-up question on that. Do you only do it, or do you repeat this process, let's say, during the course, or is it only, you know, like the...
I mean, what we say is that the whole course is an iterative process. Yeah. So, so there's some students, for example, last week, we've asked them to go back and rethink of the problem, or we asked them to go back and re-elaborate the future vision. So, so there are these kind of the design thinking, let's say, milestones that we follow through the course. But we always, you know, say, you know, be ready to start again. Be ready to kind of, and we've seen that. We've seen students like the last 4 days of the course, right before the final presentation, they just come up with new solution and they pivot to something completely different. So it's not a linear journey for sure.
Yeah, thanks.
Yeah, Nina?
Yeah, thanks so much for your presentation. It was really, there's so many things in there that I could ask questions about, but I've settled for one. I was wondering, you were showing this image, I think, about learning goals, kind of on several levels. Yeah. And I was wondering about the bottom level, which I think was called something like meta-cognitive or meta-knowledge. Mm-hmm. I was wondering how you position this within the course. Like what are, or I mean, do you position it in the course? Is it something you specifically also discuss with students, that this is one of the goals that you have? And then also, how do you coach or guide students around this type of knowledge development?
So very, very good question. And again, this is one of the new, every year we add new elements and experiment ourselves. So, and then what this year we added is kind of, we tried to make the learning objectives more clear and then kind of realize that it's so important in the, especially when you teach them how to innovate and kind of to reflect and adapt in the process of learning. So what I like more concretely, what I'm asking the students to do at the end of each day is to do 3 sentences, to write 3 sentences, which is today I liked, this is this, today I learned this, and today I wish this. So then, and we are doing this with, we have some kind of other projects that we're going to create this, we'll use this and see how it works or not. But this is very concretely what I'm asking the students. And then when I first said that, I wasn't following up with the students to check if they're actually doing it. At the end of the course, we do ask them to write, and it's part of their grade, to have like a reflection essay. But then some of our colleagues intervened and said, okay, if you ask them this, how about we have them fill this online every day. And so now in the middle of the course, we ask them to go and actually fill this online. But this week, towards the end of the week, I'm actually going to sit with some of the students while we're there and actually ask them if they thought it was helpful or not. So to see, to me, I mean, and I don't know, I mean, in all, if you look at some of the trends in general in productivity, it says that it's always very good every day to reflect on what you're thankful for. So it's in a similar way that we're asking the students, you know, reflect what you learned today. But again, ask me in 2 weeks, and I will be able to answer whether this is effective or whether the students thought it was a horrible idea or not. And I will let you know.
I would love to know. Yeah, I mean, I feel that reflection is often so crucial in these types of courses, but it can get so many different shapes. You can use it for so many different things, even if it's for productivity or for also in design, it's so important. So yeah, yeah, it's just a curiosity thing of mine, I think, to see how this shapes in CBL courses. And yeah, so I'm curious about hearing more about your journey on that specific topic.
I'll let you know. Yeah, I'm trying.
Yeah.
I mean, I'm actually also where did I put it? The auto documentation of self-awareness. We also talk a lot about it, the teaching and coaching stuff as well. Like for me, I keep kind of recording every time, you know, reflect how the students are thinking or auto documenting the process. So I'm making note of everything and happy to share.
Yeah. Yeah.
And I saw now, like on the chat, a note about the emotional learning journey. And again, there's so many where, I don't know if I've put it here. There's a lot of research about emotions and innovation and the learning process. And we see it year by year. The students go through it. I go through it myself every year. I'm like, oh, why am I doing this? I start being fun, and then at the middle of the course, we're like, oh, this is not good. But then you come out of it, and then it's all worth it. You feel like it's all worth it. Yeah. I don't know if there are any other questions. I think now we're back on the time slot that Diana originally had assigned. I don't know if anyone has anything else to ask. Otherwise, I'll stop sharing my screen. And okay, there's one more, Jorge.
Yes, thank you, Kyriaki. Fantastic presentation, I have to say. I just want to ask you if you have already designed a way to evaluate, I mean, the results, if you have an instrument or a specific technique, because all we, work with challenge-based learning, but I don't know if you have a specific instrument for evaluation.
This morning we had actually a meeting and we talked about this. Yeah, I mean, I'll show you. These are my notes from this morning's meeting. Oops, I don't know if you can. No, you can't see. But yeah, so we are. we will ask these students, we're going to try and have a survey that is attached to the reflection deliverable, so that we had a better understanding of how they perceive their learning and what they've learned. But again, part of my task this week with my colleagues is to create this evaluation metrics. And again, I'll be happy to share with you. And a survey, we were talking, measuring learning is challenging in its own terms, like for let's say traditional courses, and it's only more with the kinds of courses that we're doing. So again, I'll be happy to share what we end up, the survey and the metrics we end up delivering, coming up with in a week. So in a week or two, I'll be able to, we can connect again and I'll be happy to share everything I know.
Thank you, Kyriaki, for your presentation, and what an interesting discussion also to witness. We're moving now to our third speaker, Emanuela Tilly. And I'm very interested in your approach at UCL.
Unmute. There we go. Unmute. Last thing I have to do. Hello, everybody. You can see my screen okay?
I confirm, yes.
Great. So I really liked Kyriaki's presentation, and there are so many things in there that we are going to discuss to be very similar. What I'm going to focus on are interdisciplinary projects in the early years of education. So we're talking about first years and second years here, and how perhaps we can develop some of their skills and their understanding, because we found it to be very different than the more mature students. So I'm the director of the Integrated Engineering Program, and I should give you a little bit of a background in terms of at UCL. So this program is not a degree program; it's a teaching framework, and so across UCL we've got quite a lot of undergraduate programs, and these are the things that we put into all of them. So interdisciplinary studies, whereas before they were very discipline specific and very autonomous. So we've done that through aligning with our research, because they are more interdisciplinary than our education, and the industrial sectors that we have partners with. We took the approach to go through authentic and contextual learning, so trying to bring in more real assessments, more challenges that were real. The SDGs certainly come into that, but also trying to get them to learn, the EDI values and align with our EDI values and the experiences that they will have. Because there will be many of them that we introduced were team-based. So there's quite a lot more team-based assessment, even from the first day of their first year. And so the way we've put this teaching framework in, or mandatory learning, we have a professional skills development backbone. So there are modules from first year through to second year where they focus on skills. So it's a skills-based learning, and this is alongside our challenge-based learning. And we do that particularly for their employability. So we really aim to strengthen that. And of course, our mathematical modeling was completely rearranged and remodeled, and that has been also part of the integrated engineering program. So I will talk about these elements a little bit more in my next slide. So just to give you a sense how big this is, these are the individual departments that we had and the undergraduate programs. So we've got biochemical, biomedical, chemical, civil, electronic, and electrical, mechanical, computer science. And we've also got the business school with us, or school of management. So we've got a management science degree. And so the teaching framework puts, across all of these programs, some fundamentals into the core curriculum. So our mathematics was completely revamped, so that comes in the first and second year. But you will see quite a lot of blue and green on the screen, because the green is the projects and the blue is the skills-based learning. So all of our students now have skills-based learning and quite a lot of projects. The first module being the engineering challenges, which I'm going to focus quite a lot on because it's the first term of their first year and it has over 1,000 students on the module. And then what we call scenarios. So scenarios are 1 week intensive projects where they don't do anything else. We've carved out a week so that they don't go in any other class, but they do projects that allow them to work on content and develop skill sets that are associated with the skills module, but also with the modules that they're learning across the term. And then I'll just briefly talk about how to change the world because it's our interdisciplinary capstone project. And then also our integrated program we now have a student in minor pathway. So students from chemical engineering can do programming, or, you know, they've got 19 choices of different minor pathways that we've curated for them. And because of the IEP now, our 3rd and 4th year projects are no longer just discipline specific. These are the traditional projects that the UK has for accreditation. And I know that that's similar across the Europe. But now we have an opportunity to bring students together across disciplines to do their projects together. So this is how I would articulate our spine of project and problem and project-based learning. So for the incoming student, they have 2 challenges in their first year, first term, up until Christmas. And then in the second term, they've got 2 scenarios. So it's right through the center. And in their first year, you know, clearly this is not of scale. So their discipline specific technical content and the maths make up, I would say, 70% of their learning. But the challenges, the scenarios, and design and professional skills are the new things that we've added. In the second year, they've got 4 scenarios, and then how to change the world, where how to change the world and the challenges are interdisciplinary, but the projects scenarios are discipline specific. And the really important thing here is we tried to create the spine. So 1, we can get away from our modular delivery of knowledge and subjects, but also so that we can do true project-based learning where we teach the skills elsewhere and the content elsewhere, which is in the core modules at the top there, and they do project work. So they come in and they work on projects, and a lot of the content that's delivered is elsewhere. So the arrows are really, really important in the way we deliver it. When I started at UCL, it all started with the subject. The IEP was kind of given to me in this framework, but we had to create what it was. And one of the first things that I did, because I have an industrial background, so I was specifically hired because I was working 8 years in industry, and they really wanted to get some, authentic learning experiences through my practice. And so one of the first things I did is I partnered with 2 professors that were in the civil engineering department. Both were visiting professors, and we came up with this definition that really resonated with staff and students from across the faculty. And here it really highlights that engineering is a practice. So we've got to put a lot of hours in, a lot more practical parts of the curriculum and opportunities for the students, but it's an art. So we really wanted to cultivate the creative process. Of course, students change the physical world, but we needed to put people back into the center of what they do. So we wanted them to start focusing on the social impacts of their work, and not just the social impacts. And so we together realized that design was at the center of this. So we needed to introduce a design curriculum. And so instead of working with designers, we want our engineering students, whichever discipline they study, we really wanted design to be the core process and in which to navigate quite a lot of these projects or the challenge-based learning. So we bring design to center stage. And if you think about design historically, design was always more of a downstream step where it was, just really to put a wrapper around the idea. Aesthetically, we needed to make it pleasing. That's how designers were thought historically to add value. But now design is central to create ideas that meet better societal needs and desires. And so one of the principles of design that we like to focus on is the mediating principle, which is here taken by a quote. I like the way this is defined, that we design to shape a relationship between human beings and the world. So our work really kind of helps formulate that relationship. So the former role of design is tactical, which was very limited in its value, but the latter is strategic and can add very dramatic and new forms of value. And I really liked how Kyriaki has presented this in her presentation. So for us, that strategic view is the process of design. And if you think about it, Kyriaki's definitely presented a way that they've let their students go through. If you look at industry, IDEO being a design company that have also published design thinking and their design processes. Design processes can go very broad, very much like what they call their process, which is inspiration, ideation, and implementation, to something where we really acknowledge and we recognize the four categories of design, and the Royal Academy of Arts here in London call it their arch of golden arch of design, where you go through discovery, define, develop, and delivery, and you're impacted by the past and you have visions of the future, but you have to, if you just looked into the concrete, which is this horizontal, you would only just deliver and through your discovery, but really want you to consider the abstract. And that's why it's a golden arch instead of more of a linear line. And then the discover, define, develop, deliver framework is very similar to the UK Design Council, where they look at the double diamond model. And this one is very universal. They're, something probably you've seen before. But in this one, very much so, they talk about that thinking process of divergent, convergent thinking. But also here, the way it's presented, how there is that problem definition, very much like how Kyriaki has said that there is that definition before the ideation, and then there is the solution part of it. And here it doesn't show you temporally which diamond is bigger, or that there is an iteration process where the arrows should be going both ways. There's the CDIO process, where it's conceive, design, implement, and operate. I really like the Singapore Polytechnique design thinking framework, where they brought in sensing and sensibility, empathy, ideation, and prototyping into the conceive and design, because it goes from the broad and bringing in extra ideas. But for us at the IEP, this is our design process. And we did this because, first of all, we needed language that was going to represent all of our disciplines, from computer scientists all the way over to the biomedical students and the chemical students. But also, I think from my experience of working in industry, making decisions is possibly one of the hardest things that engineers have to do, knowing that in many cases, the information is just not there. So we put this to be more of a decision-centric model, understanding that there's a need, there's a time for a brief, conceive, test, instruct, make, use, and then that yellow arrow is most important, so that the need or whatever problem that we have and what we create, there's a connection there, or there's a learning experience there. So that's our design model, and we'll go through it a little bit in terms of what we do in the classes. But what we like about design is how it connects creativity and innovation. We all know that creativity is about generating new ideas. Innovation is about exploiting those ideas. Well, Tim Brown at IDEO believes that design and design thinking shape the ideas to become practical and attractive propositions for people to purchase, view, or adapt or use. And design may be described as creativity deployed to a specific end. And I suppose that design thinking just really helps to frame the design process. Another model we use is the critical thinking model, or the context for an innovation model that Tim Brown has wrote about, apologies, but we use it as a critical thinking model, where students, when they think about what they're designing and what they're making, they're always thinking about feasibility, desirability, and viability in this language, so that they're thinking about the people, the business side of thing, as well as the technology, and then the interfaces between them. Because as Tim's model says, the innovation sweet spot is when they all align. And so we introduce this language to our students from the first year to really critically analyze their ideas and start thinking about those trade-offs. So when we teach engineering, it's in context, and the context is often very rich. this is one of the slides I tell my first year students in the opening lecture, is that we know that they're very strong in maths and sciences, and those principles of science will guide them through all of the work that they do. Particularly they go into more advanced studies in their degrees. But right from the very beginning, we have to start thinking about risk, ethical issues, social issues, environmental issues, and financial impacts. And of course, our engineering students are perhaps much more comfortable with the areas of environmental and financial impacts, because financial is fairly logical and mathematical, and environmental, they have a passion for it, and they relate to it so much more than they perhaps would with risk, ethical, and social. So those three are the ones that we really want to start focusing on and supporting our students, because at the end of the day, we need sustainable designs and innovative solutions. But we should all agree, and I think we've seen this in Karyaki's slides too, is that design, the problems come first. And so if I think all of us that teach in the area of challenge-based learning, that the students often try to sweep past the problem and go straight to the solution. And possibly it's because some of the things that we want them to consider are uncomfortable. So, you know, we've heard things like emotion, and we've heard about empathy, and we've heard about, you know, other people, you know, interviewing people. Those are things perhaps feel a little bit foreign to students. But if we are embracing engineering design as a process, then we should perhaps look at those early stages of the challenge. And so for us, we kind of frame that as being what we call the inquiry-based iterative process. And what we really like about this is that at the end of the day, from my experience, engineers have to create a brief. They need to articulate what they understand of the problem and how they can put it in language that's going to be measurable to them and measurable to the client. So this iteration loop is something that we focus whole projects on, really, where we have the need, the students are writing the brief, and they need to make the decisions in order to do that. So they need to understand the need. We do walk them through and talk through stakeholders and mapping, particularly power interests analysis. We do a lot of site and community research, much to the chagrin of the first year students. I had a first year student, we had a project in Peru once, and they said, why am I spending all this time thinking about people in Peru? And I said, because your solution at the end of the day really does have to align that future thinking, much like Karyaki said, about how you think they will use it. So you need to know about the student, the site and the community, and that research is essential. But redefining the problem, defining key terms and language was really important for students. Some really breaking down a lot of steps, if you like, of trying to understand the problem. Trying to establish objectives and criteria, and write that brief. And the brief is very, very basic. It can be. It's we are taking on this problem because this is who has it, and this is why they need it being addressed. And so we also ask the students to understand the assumptions that they make, ask the questions to be able to verify and try to find more answers to validate their assumptions, do a lot of research and estimate before they decide and justify. And so then the output of that is really trying to help them generate their ideas. And so this presentation is not so much about the conceiving, testing, and prototyping, but the link for us between the brief and that whole iterative step of the conceptualization is really their state-of-the-art report. So we get the students to start looking at what currently is out there, what currently the communities, let's say if they're in Latin America, looking around Latin America for other, existing ideas, but also innovation and technology and that sort of thing. So we do like to break it down because we feel that this next iterative loop is very practice-based. So I'm going to just talk about the two instances that happen in the first and second year that are interdisciplinary, and why I believe interdisciplinary projects are probably the best for helping students explore that social responsibility and the social impact. And I'm going to go in reverse order because the first year, we've done so much work in the last 8 years from when we first delivered it to where we are now, that I think that's the real information that you want to hear, is how we really supported the first year students. students. Our second year, we have How to Change the World. And so this is what we call the capstone of the IEP, because most of the IEP is in the first and second year. And so How to Change the World is bringing all of our students together. It's more like 1,000, 1,100 students each year now. And we have quite a lot of industrial partners, community partners, and quite a large teaching team. It's only 2 weeks. It's a real intensive project right at the end of their second year after their exams. It's quite a delightful project, and they all feel as though this is the thing they talk about that lets them stand about the crowd. But situating it as a socio-technical problem, so giving them the SDGs and framing it more of a social project so that they come and bring solutions in the engineering space, is something that is difficult. It's very well placed as a second year. We've had guests come to us and to see the experience, and many of them have said, well, I couldn't possibly put this in my curriculum. And it's because the students have never done PBL and they've never done, design. And so we feel that there is a stepping stone process, if you like, before they can really take on the socioeconomic problems. And that needs to be that they have to start thinking about working in a team-based environment, a project-based environment where there are open-ended questions and challenges, but that the socio-technical aspect of it is really a layer or an add-on that we can introduce once they've started doing some projects that are more constrained. So these are our partners. It is very much a showcase event. Our students are primed for this. They have done 8 other projects before this. And so it really gives them an opportunity to take their experiences and shine. And we've tackled, almost half of the SDGs since we've started this back in 2012. And so it's really interesting that we actually started the How to Change the World before the IEP was put in. And in the first 2 years, it was really difficult for our students to take on such a project without having done PBL before. The engineering challenges is this first term project. Actually, there are 2 projects, but it really is our cornerstone. And so it was built around the framework of how Felder describes project-based learning or collaborative learning, or integrated learning, where the approach is to introduce engineering problems starting in the first year and bring maths and sciences in, but also start bringing in things like communication, economics, and ethics. So communication is a skill set, and that's why we have design and professional skills there, so they can learn some of those techniques to be able to introduce that. Economics is something that our students gravitate to because they're very good in maths. And ethics is certainly something that we put in, but we put it in through the context of the problem. We don't explicitly teach ethics until after this course, so that we can start talking about the context before they start thinking about ethics and classical ethics. So in the first term, our students have a maths course, they have the design and professional skills course, and then they have their intro to their engineering course, so discipline-specific intro. And in this course, it's about teaching them how to work together in a collaborative way. They practice and then they reflect. And both challenges are project-based. I'm going to focus on the second challenge, which comes after about 3 weeks. The first challenge is shorter, sharper, and it helps them get integrated into UCL. But the second challenge is interdisciplinary. And from us, our philosophy was that design means that we bring everybody together from the start. So bear with me as I introduce you to this project. This project has students from 7 departments working together in 3 project areas. So we've got the biochemical engineering students, biomedical students, and they're working on a bioreactor. Our challenge is based around that. It's TB vaccine production in Uganda and East Africa. And so then we've got the other disciplines working on the control system for the bioreactor, and then the power system and the water system. So we break down all of our students into teams. One team consists of these subgroups, and the subgroups, as I mentioned, are there. So we've got our disciplines paired, but one team is considered those 4 subgroups. And in a couple of years, we also had our security students, our security and crime science students adding an element. And so I just want to take about 3 minutes to tell you how we've walked through how we support students with the social responsibility and impact element of this project. So when I delivered it back in 2014 to 2017, what my focus was bringing in authentic learning experiences with an interdisciplinary PBL experience. And so I wanted it to be a contextual challenge. And what I put in was they would meet workshops. They would do 4 hours of workshops in class where they're just working on their project. And then they had weekly meetings as well. So they would meet students from across the disciplines to start talking about how their projects can interconnect. So the bioreactor would connect with the control systems and the water system, again, to the bioreactor. And so we did that so that it was kind of like subcontractors talking, you know, in a subcontractor meeting. And so that worked okay for them to understand the interdisciplinarity, and the social impact was just talked about through the project. So in the workshops, they talked about, you know, water and sustainability and risk and security, and it was just assessed through the final projects. Okay, so the final report and the assessment. But it was a real hurdle just getting a contextual project in the first year. And then Kate Roach came on, and in 2 years, she changed those weekly meetings because the interdependencies were actually really frustrating the students. So instead, she put those meetings as thinking about the social responsibility and the impact of their design work. And so the students from across the disciplines started talking about their work in 4 areas, which was cultural context, risk and security, ethics, and sustainability. So all of these meetings, as you can imagine, a lot of them are happening at one time. These were all PGTA led. And although the students really liked working together and meetings so that they could inform what was being written in the report, it was still very difficult for the PGTAs to get a consistent led experience because it wasn't academic and we had to teach the PGTAs to do it. But it was students really liked talking to other students across the disciplines about it. And then now, currently, because of COVID, we had to flip this. So our main focus was just trying to get interdisciplinary learning online for the last 2 years. And with that, we had to remove those weekly meetings because it was just too difficult to timetable. So instead of putting it in the team report, we now have an individual social impact report, or sometimes in the technical factor report, so that students understand that this is wider than their project. We kept with the areas. There's quite a lot of support online. But here, again, we kind of tried to focus those 4 areas as how do we reduce harm when we understand cultural context, risk, ethics, and sustainability. And just bringing it down to reducing harm in the first instance for the students in the first year was really helpful for them because these can be quite hairy topics. And it was assessed through a 1-page written report. And I think the students really liked the freedom to be able to reflect on what they learned as well as what they researched about the project. So this is this 2-page report, even though it's higher in length and they do more work individually, I think they're really enjoying it. And so what I just want to kind of finish off of is interdisciplinary projects are quite unique. We've done a lot of research in terms of observing PBL and our students through the PBL. So we did a major study in 2019, and it was reproduced at Reese as well as some local conferences. And what we learned from the discipline-specific projects is that we know that projects are an opportunity for students to create new technical knowledge, both on their own and collaboratively. But also our students, the observations were such that disciplinary projects give students an opportunity to learn some and operationalize some of their own problem solving and solution finding techniques that were specific to their discipline. But what we found from multidisciplinary or interdisciplinary projects is that doesn't matter if they go into the project in the first year or the second year, our students come into the project with an assumed identity associated with their discipline. So they really want to kind of represent and do learning in that area. So our students, however, one of the biggest things was that students are open to understanding perspectives from students from other departments and participate in more dialogue, particularly investigating the project in the first part of the project and not rushing to solutions. So they're using the critical model, critical thinking model much earlier than they are in the discipline-specific projects. So we found that as to be quite an insightful finding from the observations of this in the study that spanned between the 2018 and 2019. And of course, the students love learning data analysis, testing, and prototyping techniques from the students from the other departments. And I just wanted to kind of finish off because my colleague Kate Roach, who is the person that has really helped us push in this area and over the years. She will be presenting in the next SEFI Work Ethics session, and she'll be talking about how we're moving into responsible innovation as a framework to help our 4-year IEP framework to move forward and address some of these issues. So the integrated engineering program has authentic learning via PBL, and we have the design-based learning to help them navigate through BBL. We've also got a skills-based thread and a space for them to learn the skills and some of the concepts before they actually explore it. And now for us, we really want to get the students to dive deeper in their exploration of social responsibility and social impact, particularly in their final years. And we believe that social responsible innovation is the framework that we want to use to be able to do that. And she will be talking about that in the SEFI at Work session in May. So I'd like to thank Kate and Fiona because they were my 2 colleagues that really helped the Engineering Challenges first year module evolve from the beginning of the IEP all the way through to the impacts of COVID and now post-COVID. Thank you very much. That's the end of my presentation.
Thank you, Emanuela, for such an inspiring presentation. And I love to see the synergy between you and Kyriakis' approaches, and also how you mentioned your colleagues that shaped in one way or the other your approach. I am again regretting that we are short on time to address any live questions for Jorge also to have sufficient time to present, but I welcome any comments or questions via chat, and Emanuela will pick them up. Thank you very much, Emanuela, and Jorge, please, looking forward to the presentation of your approach at Monterrey.
Can you see my presentation? Can you hear me well?
Yes.
Yep. Okay,
Yes,
well,
good.
thank you very much. Thank you very much for inviting me to this very important seminar. And today I'm going to talk about challenge-based learning as a tool for acquiring skills on the path of transforming society. This is the way we are now working at the Institute for the Future of Education. That is a new institute that has been formed in the Tecnológico de Monterrey. That is one of the best universities in Latin America. And I think probably you will know about it at the end of this presentation. Okay, the main problem is why education has not changed as fast as the technology has changed. For example, probably you remember the telephones. Most of us, we are old enough to remember this type of telephone, but now we have a very small telephone and we can communicate everywhere and whenever and wherever you are, or the cars. But what is very interesting is that the classrooms are very similar from 50 years ago and until now. And the thing is that what changes the way we teach And probably the main change has been given by the COVID-19. The COVID-19 pandemic has changed the way we teach, and then we need to adapt. And one of these things I have to say is that education has always been seen as the main tool for transforming society. But the society has also transformed education. And for example, we can understand that if there is a very important advance in STEM education or in STEM, tools or technology or engineering, probably we are giving solutions to a social problem. But some situations, social situations such as the pandemics, for example, that is the main example that we are talking now, has changed the way we teach. And this is a very important thing, because then it means that education and society are in an interrelationship, but a bidirectional arrow, I think. And then we need to use education to transform society. And how we are going to do that, we have to prepare the students to overcome challenges and to face challenges. Today's challenges are very important, as we heard from my previous fellow speakers. For example, climate change and many, well, now the war, pandemics, things like that, that we have to be prepared for, and the students must be prepared for. And we have to remember that the skills that we prepare the students for are not the same that we were preparing them 10, 20 years ago than now. Now, for example, in the last 2 years, the digital competences have been, given an uprise in the priorities of the competences that are required for stakeholders. And let me tell you that some of the theories of education we have learned about cognitivism, constructivism, humanism, and now behaviorism. We need to know that we have been changing from these theories, but now what is very important to face the reality is the experiential learning theory. And I'm going to, any of these references can be asked for me, or you can find them. Now it's very easy in Scopus. This was mainly described by Kolb. And the thing is that to acquire knowledge through experiences. And then what is the sentence is new knowledge is built and new competences are developed to apply what has already been learned to a new situation. But what is a competence? We have to learn that, now we are teaching and evaluating competences more than knowledge. And competence comes from competere, that is a Latin that means to respond. And competence links knowledge, concepts, abilities, attitudes, values, strategies, and skills that are acquired to knowledge. And then these competences are actually what we need to prepare the student for to respond to demands of the environment and society. We saw by my previous speaker from the UCL, Emanuela. I really like UCL because it's our brother from King's College where I got my PhD, that sustainable development goals are the goals for the future. But some competences, for example, we know the self-knowledge and management, innovative entrepreneurship, social intelligence, ethics and citizenship, reasoning for complexity, advanced communication or digital work, all of them are described, they have a description that we may be able to evaluate. And the instrument that we use or the technique we use to evaluate, well, has to be with the challenge or the way we are preparing the students for developing these competences. But not all of them are in the same challenge or in the same technique. Then we have to understand that now the education has to shift from what is the contents, the curriculum based on subject and contents, to a curriculum based on competence and development and based on challenges. The subjects as the basic elements for curriculum design. Now the challenges as are the basic elements for curriculum design. The evaluation of knowledge in the subject, we have, remember in the past, we had only exams or probably some practical things or problems. And now we have to evaluate competences through challenges. We had in the past sequences of courses, Math 1, Math 2, or Physics 1, Physics 2. And then now we have the modularization. It means parts of the project in the same semester that gives flexibility. Before, the professor had different multiple roles, but now in the past, the professor had all the roles, was the mentor, was the guide, was the teacher, was the co-researcher, was everything. But now the teacher has to ask for help for many other multidisciplinary teachers to try to solve a challenge. And in the program that now, for example, here at Tec de Monterrey, in the past, we had a decision of major from day one. If you want to be a chemist, okay, you are going to be a chemist from time zero, or if you want to be a chemist now, you have a pathway. It means that you have to explore the area, decide, and then specialize. In challenge-based learning, I would like to say that this is the technique or the theory we are now speaking about today. Challenge-based learning is an immersive, it's a technique, it's a didactic technique that actually exposes the students to real challenge. These real life societal challenges of the future, it means that the students are going to be learning, solving challenges. And normally these challenges has to be in line with SDGs, as very well was explained by Emanuela and Chris. And we have to understand that this challenge is the middle of the relationship between students and teacher and the environment. And this challenge has to be solved by the modularization of contents. And what is a challenge, and where are we going to get the challenge from? Who is going to give the challenge? Who is going to propose the challenge? The challenge can be proposed internally inside the school, a challenge that has to be solved by students and teachers, or probably we may have, as the Tec de Monterrey has designed, a training partner who has several challenges that has to be solved by the students and teachers. But this is a very important slide that I would like to stop a little bit to differentiate what is a problem-based learning, project-based learning, and challenge-based learning, because they have different learning objects, design problems, specific tasks, or real-world problems. Although some project-based learning may have real-world problems, the difference between these three different didactic techniques is the main difference is the uncertainty and the role of the teacher. In the case of problem-based learning and in the problem and project-based learning, the teacher has the control of everything. The teacher has this. The teacher knows the solution of the problem already, or probably the problem has been solved previously for many generations. Or in the case of a project, the teacher knows the answer or knows the end of the project. In the case of the challenge-based learning, the uncertainty is so high that probably the teacher is not even an expert on solving the project. And the role of the teacher in this case in challenge-based learning becomes a designer, a coach, and a co-researcher. Then it means that the teacher is part of the solution of the challenge. And remember that the evaluation is not the solution of the problem of the challenge, sorry, but the way and the competences that are acquired to the challenges. Then I have to make these two remarks. That CBL, challenge-based learning, emulates experience of the modern workplace. And this is a very important thing because some of the employers now, they ask for several competences. And some of the competences that are developed specifically in CBL are tolerance to frustration, collaborative work, resilience, development, collaborative work, I said twice, sorry, decision-making, and leadership. And this CBL, actually, this requirement fits perfectly with Generation Z and Industry 4.0. And then probably this is the way to go to make students or to prepare human resources that are, fit for the future. In our school, in Tec de Monterrey here, we transformed the way we teach 3 or 4 years ago, implementing the new Tec 21 educational model. And this Tec 21 educational model has 3 pillars. actually 4 pillars, but these 3 pillars are the pedagogical interesting for us. One is flexibility, that is a very flexible way of teaching. Inspiring faculty, very prepared teacher that they have to change the mindset and to become very interactive with students, and challenging. All the classes, all the courses are now challenge-based learning based. And I'm going to talk quickly about, for example, how we apply these challenges. And in this case, we had a training partner that is a pharmaceutical company, Boehringer Ingelheim. And this pharmaceutical company that is in the surroundings of the campus, the teachers, these are some of the teachers that we went to the company to see what challenges they have that we may adapt to our courses or to our CBL strategy. And they had this problem with the blisters where they pack all the tablets. And the thing is that this was a very high contaminant product. And the thing is, what could we do with that blisters, with the materials, to avoid the contamination and to actually to lower the fine that they were charged by the European Sustainability or the Environmental Agency, because they had to pay a lot of money because they didn't have a way to dispose this waste. And then I think the main step in the challenge-based learning is to prepare the teachers, because the teachers have to change the mindset to be a contents teacher, to be now a challenge-based learning teacher. And this is a very important thing, how to change the way we teach and how the way we actually evaluate. At the company, at the training partner, they have also a specialist, these engineers that actually are in charge of the project or this challenge, and they give all the information that is required to solve the problem. And now this is a very hands-on experience for the students. And at the end, we have the evaluations. Actually, we published a paper recently in testing different way of evaluating the students that have had this kind of experience. And actually, I have to say that we learned that using these checklists and also rubrics were I think the best way of evaluating the students. And but we learned that doing this CBL, we promote the autonomous learning, and this is a very important thing for today's students. And this is a new concept that we would like to introduce, that is the socially oriented education. It means that probably we can take some of the challenges that are actually in society, and then we may design programs in challenge-based learning in order to solve those problems. And this is the way we want to develop in our Institute for the Future of Education. We have evidence, for example, this is a very important experiment of learning gain. Probably you are familiar with the learning gain strategy. And we have 2 parallel courses. The one face-to-face course, that is the front bar, and the same course, but doing challenge-based learning are the back bars, the darker bars. And as you can see, the learning gain was in 4 different semesters was higher, significantly higher, the learning gain of students. Some conclusions so far. We have to say that in CBL, students work with teachers and experts that are not the main teachers in their community on the challenge. And what is a challenge? The challenge, as I said, is a very high uncertainty situation, and it's a very real life situation. Always this challenge triggers different associations of experts and teachers and everything. And one of the main elements is uncertainty, as I said. And we need to solve the challenge together in a collaborative work. Some of the elements or uncertainty are, the freedom, degree of how to approach is a very, very good one. The students actually appreciate that they are free to, to approach the challenge. This multidisciplinarity, present in the solution of the challenge. It's an authentic real life education, and always we have to check for the competencies as an evaluation criteria. I have to say that this is just published, I think, 2 years ago, before pandemics, and these are the engineering employability skills required by employers. And in this case, we have several, 3 different places here, the UK, Singapore, and Japan. And I have to say that digital competences and sustainability competences are now very high in priority. Well, I have to say 2 more things, only that this is my email and this is my my webpage. Well, I belong to the socially oriented interdisciplinary STEM education research group. And finally, I have to say, if you allow me to invite you to apply to a postdoc position that we have. If you have any fellow that you may propose to us, we have a postdoctoral position for this group and to study this educational research group in socially oriented education. Please refer to my email for more information. And that will be, thank you very much for everything.
Thank you, Jorge. And I'm glad we can have now a discussion, and it might be an opportunity also to bring all the presenters together to address any questions or comments you might have. So please feel welcome to raise your hand. Kirsten.
Thank you. Thanks so much. Really, thanks very much for the presentations and for the organization, Dan. It was really very, very interesting. My question could be answered, I think, by any of the presenters. It's about the ideas. I know that often the point of the activity is not innovation in itself, in that the students are learning their skills and professional skills and their engineering skills and everything else that has been talked about. But how important is it that the idea itself is evaluated and is a good idea? And maybe going even further, how often does an idea from any of your programs actually go further and become something? And I know it's really challenging to do that when students are brought together in an ad hoc group, and you need mechanisms and facilities and resources to take an idea from idea into the marketplace. But I'm interested in any of your reflections on that aspect.
Yes, may I answer your question? For example, Kirsten, yes. For example, in this case that I mentioned about this group of students that try to solve the problem of these blisters, these plastic blisters, and you know, this package has some plastic and some metal things. They actually decided to separate the chemicals. I mean, the magnet with a magnet, the metals to the plastics, and now the plastics, they actually shred it, you know, they crush it, and they made like now they are a material for covering some tables and things like that. They give you know, a longer life cycle of the materials, and in that case it was very sustainable, and now they have an enterprise on that. And what the schools did was to follow their case and actually help them to, you know, to start up their enterprise. But that was, I mean, the following up of the students. But that's the case I mentioned.
Just to say for our students, because I usually work with first years and second years, there isn't a lot in terms of the ideas going further in terms of startups and that sort of thing. That tends to happen more in the third and fourth year projects where they go into that space. But I will say that we tend to bring in the community leaders, or there is an interaction with the community or an external partner. And what they really like are the students' ideas that just spark their own ideas or thinking elsewhere. So that because a lot of the community partners don't have engineers in them, they do bring out some new things that they come in, particularly around the research. So our students do a SOTA all the time, and for them to go out and say this is valuable information to say what's already out there that can help you is where we would base a lot of our foundation in terms of what's good and what's not. That's really helpful. The other thing as well is that critical thinking model that we talked about. We evaluate their ideas based on that. Technically, do we think it's going to work? That's feasibility. Is it financially going to be viable? Are you using something that the community can get very easily? And then desirability. Have they thought about that? So that's how we measure their ideas, and it's in our assessment plan. So, and they get very familiar with that all the way up to third year, so third and fourth year.
I mean, I can just say briefly, Kirsten, I really like your question. It's a very good question, and in fact, because I feel like just this year, I started changing the way that I refer to the challenge-based innovation as an innovation and learning journey. So I keep telling the students, this is an innovation and learning journey. And of course, it's still hard to distill the difference, and figure out the moments where, they're learning about innovation, they're learning about learning, they're learning about SDGs and all design thinking and all sorts of things. But it's a very critical question, and I think it deserves a study on its own. What do we evaluate in this journey? And it's this kind of really nice relationship between learning and innovation. And there aren't even many academic articles about that. And how, like in our case, within an academic setting, it is both. So
I would love if there's any follow-up on there. I would love to participate. I run a design agency, and we've done challenge-based learning type activities since about 2005. Actually, I didn't know that's what we were doing at the time. I was doing it from the company perspective, thinking, but in fact, that's what students were doing. And we're starting to look back at a population of about 20,000 students who've been through those challenges now to see, well, what did any of them actually do in innovation or in design or startups and so on. So I'd love to participate if you do ever do a study on that.
Yeah, I think the other thing that I would say, and you would know this because you're a designer, is that what the designers do very well that perhaps I've recognized that the engineers don't is the sharing of ideas. So the engineers are very precious with their ideas, right? So when we have meetings, we're with the academic and it's in a closed meeting. Whereas when I go to an architectural school, they have crits all the time. Like they're they pin up all the time. And, and because they're a stroke of a pen creativity, they're not even worried about someone else scaving off their idea or whatever. It's just their ideas almost formulate, they come from within. And I think the engineers are luscious about their ideas. So that's the other thing about not the quality of the ideas, but where the ideas come and how they let go of ideas might be about how they communicate them and share them in the process.
Thank you for how you engage with the question. And we have my dear colleague, Jan Vermont.
Yes, thank you very much for your presentations. I like them very much. I'm from Eindhoven University, and when we talk about and we experiment with challenge-based learning, some of our teachers struggle with, let's say, the tension between the autonomy given to students and, on the other hand, the call for foundational knowledge. So ideally in challenge-based learning, students can identify by themselves let's say, the theories of physics and mathematics and chemistry they will need to work on the challenges and to solve the challenges. But to do that, let's say, in a pedagogical way, it's not so easy. So I wonder whether at your institution, challenge-based learning is something that exists next to, let's say, more traditional teaching models where students learn about theories of math and physics and chemistry, and challenge-based learning is a different learning line where they apply all that knowledge in challenges, or whether they acquire actually all the new knowledge through the challenges.
Yeah, I mean, in our program, the challenges that I talked about, the first year projects, there's always a discussion with academics about how they know nothing and that they can't do this project, or that, you know, not even that, but in the UK, we feel like our degrees are so short, right? The 3-year bachelor engineering degree, we can't just throw away the project, this one term module, because the project has to be substantive. They have to learn something from it, technical. You can't just allow them an opportunity to do a project and all this social responsibility. They have to learn something from it. So that one is very much experiential, where in the beginning, it's evolved such that now it helps them with their learning in term 2. So the computer science students work with Arduinos, that is going to help them in term 2. You know, chemical engineering, learn about mixing theory, you know, because they can visually see it, and then they learn the mathematics in term 2. So, you know, they've kind of embraced that experiential learning, whereas the scenarios that we have, where we have it's effectively 4 weeks of learning in your modules that are across the term or the semester. And then you've got 1 week where the project should bring in the learning from those 3 other 4 modules that are happening. And there's usually a maths one, and there's usually a software-based one, and the others are core learning. So, you know, those are the 2 primary frameworks that we have in terms of learning. But the scenarios were specifically put in to break across the modularity and to actually get them to learn the core knowledge better. But it's hard because it's happening in parallel. So, you know, that's the difficulty, because sometimes students take longer to kind of grasp it. So they feel like they're learning it for the first time in the project, even though they've learned it 4 weeks ago. So there is always that trade-off between when they learned it first and when they actually understand it. But that's what the scenario model is supposed to do. Yeah.
I just want to add to the comments on Emanuela, that the complexity of the challenge depends on the semester you are in, as Emanuela said. Even though we have to take into account that to be a challenge, it must have a high level of uncertainty. Otherwise, it becomes to a project or a problem or a practical. And this is the way we are just checking that all our challenges actually are real life related, and in other, and the level of uncertainty may change. That is the way it's a lot of work, I have to say, to change a teacher that has been teaching for 30 or more years in a way of, you know, giving a class or, you know, in a blackboard, you know, and they know the answer of every problem, and it's very difficult, I have to say. I think it's the most difficult part to change the mindset of a teacher that has been 40 or 30 years teaching in one way to shift it to another. But I think it's the way to go to get closer to real life problems and to solve them. I think now this is what happens. Yes, Jan.
And just if you allow me to add, Diana, very quickly, I know you're running out of time. I think it's both like a paradigm shift to another way of doing education, but that doesn't mean that we don't need the discipline. I think we still need the disciplinary kind of training. So, I mean, in our case, that's why we choose the 3rd year, 4th year students, engineers. So, because I feel like it's important to have discipline-specific knowledge, technical training, and so forth, but then be able to work with other disciplines together and more real-life challenges. But exactly, like, the relationship is very kind of negotiating when does it start and when does it stop. I think Emanuela's case study is interesting because it happens in parallel. In our case, you know, we have already trained students. I think it'd be very, very interesting to explore. But I think it's both paradigm shift, but also using the best of our traditional training, let's say, paradigms, and then moving forward to the future with just kind of shifting many things. Yeah, very, very good question.
Thank you, Jan and Kirsten, for your question, and also to our speakers and to this wonderful community that was with us today. I hope you enjoyed the event, and it will be available as a recording on the SEFI YouTube channel. And We're also looking forward to seeing you to our next seminars dedicated to topics such as responsible innovation with Manuela's colleague Kate Roach in May. In April, we have a focus on social justice. And in June, we have a meeting with engineering ethics education leaders, again with Manuela's colleague John Mitchell and others. Thank you very much.